Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about two different models. We'll be looking at how to build a decision tree model and secondly, how to build a random forest model. We'll also be comparing the performance between a decision tree model and a random forest model. And thirdly, we'll be discussing the advantages and disadvantages of building a random forest model as compared to a decision tree model. Even before I proceed to demonstrate a decision tree model and a random forest model, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing you to the data set that I have. This data set is very popular. It is called as the iris data set. There are 6 variables in this particular data set. The first variable is ID. Second variable is sepal length, which is measured in centimeter. Following which you have sepal width, which is again measured in centimeter. Then you have petal length and petal width. Basically, these are the characteristics of the flower. You have sepal length, you have sepal width, petal length, and petal width. All of these are flower characteristics. You can see here the last variable that I have is what is called as the species of the flower. You have 3 different species here. The first set corresponds to setosa. The second set belongs to versicolor, and the last set is virginica. So these are the 3 sets of flower that we have. Our goal is to predict the species of the flower given these 4 flower characteristics. When I say these 4, I'm referring to sepal length, sepal width, petal length, and petal width. In this data set, the target variable is species, and there are 3 different classes under species: setosa, versicolor, and virginica. Since there are 3 different species of flowers, this is called as a multi-class problem. Secondly, since I have a target variable, this is called as supervised learning technique. What is the sample size in this data set? Let me go to the last record. You can see here there are 150 records, which means that the sample size in this data set is 150. With this introduction, I'll now proceed to Orange software. I'll be building the model using Orange software. The important thing to note in Orange is that this is a drag and drop technology. You don't need to write one single line of code to build your machine learning model. What is the first thing that I need to do when I build a machine learning model? The first thing that you need to do when you build a machine learning model is to load the data set. Let me right click and use the file option. The file node allows me to download the data set. I can double click on the file option. You can see here it is pointing towards what is called as iris dataset. Orange gives you a basic description of the dataset. There are 150 instances, 6 features with no missing values. The data has no target variable, and there are 0 meta attributes. In the second section, you are able to see the column names like ID, sepal length, sepal width, petal length, and petal width. The first 4 variables are numeric. In fact, the first 5 variables are numeric. I will not be using the variable ID, and therefore the role I have chosen to skip. When it comes to sepal length, sepal width, petal length, and petal width, the type of variable here is numeric, and the role is feature. Let's look at the last variable, namely species. Species is the target variable, and this is categorical in nature. Once we have made these selections, you can go ahead and hit the apply button. So this will load the data set into Orange software. What is the second step here? The second step here is to display the contents of the file. So let me right click. Once I right click, I can choose the option data table. This is the node which I will be using to display the contents of the file which I've loaded. Let me establish a connection here from the file node to the data table widget. Let me open it up. You can see here, we've got the 5 variables that we saw in spreadsheet. Further, if you're interested, you can click on this option which says visualize numeric values. The moment you click on this, you can see bars being displayed on each and every cell. There's a simple thumb rule to interpret these bars. If the value of the cell is large, you'll see a very long bar. On the other hand, if the value of the cell is small, you'll see a tiny bar. My first impression when I look at this particular table is that sepal width has extremely large values. On the other hand, petal length and petal width has small values. I'll remove this particular option because this is not of much use now. Let me close this window. So what do we have now? We have loaded the file into Orange software and we have displayed the contents of the file. Now we are all set to build the machine learning model, namely decision tree. Let me right click and say tree here. The moment I type tree, the very first option, tree widget, gets highlighted. Let me go ahead and establish a connection between file and the tree node. I'm going to open up this node. You can see here there are various parameters. You can adjust the values of these parameters to control the tree diagram. Let me close this. There are a few things that we need to know when we build a decision tree model. There are 5 major advantages of building a decision tree model. First is that it is easy to build and very simple to understand. Second is that it is very, very easy to visualize a decision tree model. Thirdly, decision tree can handle correlated independent variables. Fourthly, you don't have to worry about missing values. A decision tree model can handle missing values, and therefore you'll be spending very little time on data preparation. Fifthly, whenever there is nonlinear relationship in the data, decision tree is one of the best algorithms to use. So we have built the decision tree at this stage. We would like to see the contents of the decision tree. To view the contents, let me right click and simply type tree. Here you see the second item which says tree viewer. Earlier I had chosen tree. Now I'll choose the second item, tree viewer. I'll go ahead and establish a connection between tree and tree viewer. Once I open up the tree viewer, what Orange does is it displays the decision tree model here. What do you observe when you see this decision tree? A decision tree is a graphical representation of the different rules and patterns that are present in the data set. You have to follow a top-down approach. Right at the top, you can see here, there is a box. By the way, you can see here, this clearly resembles a tree diagram, and therefore this is called as a decision tree. Right at the top, you see petal length. What does this mean? This means that out of the 4 variables, petal length is identified to be the best predictor to identify flower species. So the most important driver of flower species is petal length. When you move towards the left side, it says less than or equal to 1.9. So when the petal length is less than or equal to 1.9 centimeter, you can predict all flowers as setosa. You can look at the value here, 50 out of 50. There are 50 flowers whose petal length is less than 1.9 centimeter. All of these flowers can be predicted as setosa. So this is very interesting because next time your friend gives you a flower, all that you need to do is check the petal length. If it is less than 1.9, straight away you can classify it as setosa. Very simple, very easy to understand. Let's look at the other side. When you look at the right side here, it gets slightly complicated. When you look at the right side, here it says greater than 1.9. What happens to all those flowers whose petal length is greater than 1.9. It is not easy to classify a flower whose petal length is greater than 1.9. I have to make use of another dimension, namely petal width. So a petal length whose size is greater than 1.9 cannot be classified. So I'll be using petal width. Here again, you have two bifurcation. If the petal width is greater than 1.7 centimeter, 45 out of 46 such flowers predict for virginica. So you take a flower, examine its petal length. If it is greater than 1.9, now look at the petal width. If the petal width is greater than 1.7 centimeter, you can predict it as virginica. Now you may ask me, what if the petal width is not greater than 1.7? In other words, what if the petal width is less than 1.7? If the petal width is less than or equal to 1.7, what you need to do is again look at petal length. If the petal length happens to be less than or equal to 4.9, you can predict the flower as versicolor. 47 out of 48 flowers which satisfy these characteristics can be predicted as versicolor. Similarly, you can interpret the other nodes as well. So this is how simple decision tree is. Using a simple tree-like structure, it gives us very valuable insights. You can see here the target class. Right now it is none. Let me just click on the drop-down menu and choose setosa. You can see here only the node that predicts for setosa is highlighted in blue. The rest of them are not in blue. So you can identify the rule that predicts for setosa. If you're interested in seeing versicolor, you can see here only the red color nodes are being highlighted. You'll have to go through each of these nodes and traverse the path to obtain the rule for versicolor. Finally, what you have is virginica. The virginica flowers and the rules for virginica flowers are highlighted using green. We have already interpreted some of these, so the same interpretation holds good for the rest of the tree as well. Let me scroll down and choose none. We spoke about the advantages of a decision tree. We said that it's very easy to build, simple to understand, it's very easy to visualize. There are a lot of good advantages of a decision tree. So you may ask me, what is the disadvantage? The biggest disadvantage of building a decision tree model is that it results in overfitting, which means that when you build a decision tree, you will get very high accuracy on the training data set, but the accuracy will drop down on the test data set. So this is a big problem. Let me close the window. So at this stage, we have constructed a decision tree model. One thing that we always do is to evaluate the performance of any machine learning model. Question is, how do we evaluate the performance of a decision tree model? You can simply right click and say test and score. This is the option that you can use. We can establish a connection between decision tree and test and score. I repeat, you can establish a connection between the decision tree option and test and score. This is not good enough because you'll also have to establish a connection between the file node and test and score. Let me go ahead and open up test and score. You can see here to the left side, the default option is cross validation. It says number of folds is 10. You can specify a value of 5, in which case we'll be performing a 5-fold cross validation. If you specify a value of 10, you'll be performing a 10-fold cross validation. What exactly do we mean by cross validation? This is very important. Cross validation splits the data into 10 subsets. I repeat, because we are specifying the value as 10, cross validation splits the data into 10 subsets. It uses 9 out of the 10 subsets for training the model and the remaining subset for testing it. It repeats this procedure 9 more times, each time using a different subset for testing. So cross-validation is very, very important, especially from an interview standpoint. What you see here is very interesting. You can see here the name of the model is decision tree, and along the column we have 5 important metrics which talk about the performance of the model. The easiest to interpret here is what is called as AUC, or area under the curve, which is reported as 0.96. If the area under the curve is close to 1, it means that the performance of the model is good. On the other hand, if the area under the curve is less than 0.7, it means that the performance of the model is not good. Since the area under the curve for the decision tree model that we have got is 0.96, it means that our model performance is very, very good. The second thing to note here is CA, which stands for classification accuracy. And the overall accuracy of the decision tree model is 0.95, which means that our model is 95% accurate. In other words, if you use the decision tree and the rules produced by the decision tree 95 out of 100 times, you will be able to classify the flower into the correct category. 5 times you may go wrong. Again, higher the accuracy, better the model. Next, we'll look at F1 score. F1 score is simply the harmonic mean between precision and recall. A value of 0.9 is always preferable. Lastly, we have 2 important metrics, namely precision and recall. Remember, what is the formula for precision? Precision is simply true positives divided by true positives plus false positives. So in the denominator, you have the sum of true positives and false positives. So why do we use precision? And what does a high precision indicate? If the false positives in the data set is low, automatically your precision goes up. So there's an inverse relationship between precision and false positive. If the false positives go up, the precision value comes down. So the fact that we have a very high value of precision here indicates that the false positives are on the lower side, which is a very, very good sign. Let me now go on to interpret the recall value. What is the formula for recall? Recall is simply true positives in the numerator divided by true positives plus false negatives. So you have false negatives in the denominator. Again, there's an inverse relationship between recall and false negative. As the false negatives increase, recall goes down. As the false negatives drop, recall goes up. The fact that we have a recall of 0.95, which is greater than 0.9, indicates that the number of false negatives in our data set is low. So what is the final conclusion? You can see almost every metric here is close to 1. It is greater than 0.9, which is a good sign, and we can conclude that the model performance of decision tree is high. It's a very good model that we have built. Let me close this particular window. Now, we've used 5 different metrics to interpret the quality of the model. What is the next step? The next step is to simply construct the confusion matrix. So this is the confusion matrix that we have. Let me go ahead and establish a connection here from test and score to the confusion matrix. I'll go ahead and open up the confusion matrix. Very interesting here. You can see a 3x3 matrix. Along the rows, you have actual category, and along the column, you have the predicted category. You can see here, there are 3 different species of flowers. And again, you have 3 different predicted species of flower. The diagonal elements always represent the correct classification, while the off-diagonal elements represent incorrect classification. So 50, look at the row total here. Out of 50 setosa flowers, 50 have been predicted correctly. Look at the second diagonal element, 47. What does this mean? Out of 50 versicolor flowers, 47 have been correctly classified, but 3 have been misclassified. Very interestingly, 3 flowers, versicolor flowers, have been predicted as virginica. Lastly, you have virginica flowers. There are again 50 virginica flowers in the data set. Out of 50 virginica flowers, 46 have been correctly predicted as virginica, 4 have been misclassified as versicolor. So in our data set, if you look at the off diagonal elements, you have 4 and 3. 4 plus 3 is 7, which means that 7 flowers have been misclassified. Now, you can select the misclassified by clicking on select misclassified. Let me close this particular window. You can either view this in the data table or as a scatter plot. Let me first show this as a data table. This is the data table node. Let me establish a connection to the data table widget and open this up. You can see here, these are the 7 cases which have been misclassified. The first case is virginica, but the decision tree has predicted it as versicolor, which is misclassified clearly. Second case is versicolor, but it is misclassified as virginica. Third one is versicolor, but the decision tree model has predicted this as virginica. Let me close this. To visualize the misclassified cases, I will be now building a scatter plot. Let me right click and say scatter plot. So this is the scatter plot widget. I'm going to go ahead and establish a connection from the confusion matrix to the scatter plot. Let me open this up. You can see here along the x-axis we have petal width, my apologies, along the y-axis we have petal length, and along the x-axis we have petal width. You can see here there are 7 different bubbles. Each of these bubbles represent one of the flower species. Let me first show you the default or the actual category. As you can see here in the decision tree, you have none of the flowers are shown in blue, which means that none of the setosa flowers are misclassified. You have 3 versicolor flowers. These 3 versicolor flowers are shown in red. You can see here at the outer boundary, you have 4 virginica flowers. So you have 3 versicolor flowers which are shown in red. Let me change the color option. This is the predicted category. Our decision tree model has predicted 3 versicolor flowers. It has misclassified as virginica. You can see the representation of the green circle. It is being predicted as virginica, which is clearly a misclassification. Now look at the 4 circles here. What is their actual category? In the drop-down menu, I can choose species. When you look at each of these 4 circles, each of these 4 circles are actually virginica flowers. Now, let me show in the drop-down menu what is our decision tree predicting it as. You can see here now the color changes to red, and red corresponds to versicolor, which means that these 4 flowers are being misclassified. So a scatter plot is a great tool which helps us understand misclassified cases. Let me now close this window. We have come to the end of one stage in our analysis. We have built a decision tree model. The results are okay, except for the fact that there were 7 misclassified cases. The other model performance metrics like classification accuracy, precision, recall, AUC were looking quite bright. As I mentioned, one of the biggest problems with decision tree is that it is very vulnerable to the problem of overfitting due to variance. We'll now go ahead and build an alternative model called as the random forest model. Now, this is a typical bagging technique. When I say bagging technique, it refers to bootstrap aggregating technique. What do you mean by random forest? Random forest is a classification algorithm which involves building multiple decision trees. I repeat, this involves building multiple decision tree and then combining these multiple decision trees to get a more accurate result as compared to one single tree. So in the random forest, what we do is we build multiple decision trees and combine their performance into one single model. Here, since we are building multiple trees, the idea here is that multiple trees work better than one single tree. The biggest advantage of building a random forest is that it prevents and avoids overfitting. We are going to prevent and avoid overfitting by using multiple trees. The second biggest advantage of a random forest model is that it is highly accurate and precise. And thirdly, a random forest model can handle noisy data. So let's go ahead and build a random forest model. I'm going to right click and choose the option random forest. This again is a supervised learning technique. Let me establish a connection between the file node and random forest model. Once we are through with this, we can go ahead and establish a connection with test and score. Let me check the performance of a random forest model. You can see here again, cross validation is 10. The number of folds that we're using in cross validation is 10. We have interesting results here. The first row corresponds to the tree output, whereas the second row corresponds to random forest. Let's compare AUC. When you look at AUC, in the tree diagram, we got 96.5%. Or you can just you can look at the value as 0.965. Compare this with random forest, you're getting a value of 0.987, which means random forest is outperforming the decision tree. The performance of the random forest is much better than the decision tree when it comes to AUC. Let's look at the overall accuracy of the model. In the second column, you can see here for decision tree, we got 0.95 or 95%. For random forest, we're getting 94%, which means decision tree is much better than random forest when you're looking at classification accuracy. Look at F1 score. Here again, decision tree model is performing better than random forest because it has a higher value. The same argument holds good for precision as well as recall, because both precision as well as recall is higher for a decision tree model as compared to a random forest model. Conventionally, a random forest model is more robust, it is more accurate as compared to a decision tree model. Here, only when it comes to AUC, the random forest model is outperforming the decision tree model. However, for the remaining three metrics, our decision tree model emerges as a better model as compared to a random forest model. Let me close this particular option. I like to examine the confusion metrics for the random forest. You can see here, let me go ahead. You have two different learners here. One is tree, second one is random forest. As before, the decision tree, the diagonal elements always represent the correct classification in a confusion matrix. So along the row, you have the actual species of the flower, and along the column, you have the predicted species. When you look at the diagonal elements, out of 50 setosa flowers, random forest has predicted all 50 correctly. There are no misclassification when it comes to setosa. Let's look at the performance on the versicolor flowers. Out of 50 versicolor flowers, 47 versicolor flowers have been correctly predicted. Finally, out of 50 virginica flowers, 45 have been predicted correctly as virginica. The remaining 5 are misclassified as versicolor. So when you look at the off-diagonal elements, 5 and 3, 5 plus 3 is 8. So these are the 8 misclassified cases. So you have 8 misclassified cases under random forest. So what you can do here is select the misclassified cases. There are 8 misclassified cases. If you want to examine the data set, which are these 8 misclassified cases, you can send them to the data table. Now you can see here, look at the row number, there are 8 misclassified cases. The actual species is virginica, but our random forest is predicting it as versicolor. Again, with virginica, random forest has predicted the second row here as versicolor. The same argument holds good for the rest of the cases as well. Virginica are being misclassified as versicolor. Similarly, in many of the cases, versicolor have been misclassified as virginica. Let me close this. If you want to see the same thing in a scatter plot, you can just send these 8 cases to scatter plot. You can see here, petal width is along the x-axis. I'm not changing any of these arguments. Petal width is along the x-axis. Petal length is along the y-axis. I'm going to first color it based on the actual species. Now, when you look at the actual species, all the green ones here correspond to virginica. The green ones, this is the first circle. Please observe these 4 circles. This is the first circle, second, third, and fourth. They're actually virginica flowers. Let's now look at the predicted class. You can see here, the color now changes to red, and red basically refers to versicolor. So these 4 classes have been clearly misclassified as versicolor. Let me again go back to the actual class. Please observe these 4 classes here. So their actual class, this is versicolor, this is again versicolor, and this is versicolor. There is one value which is in green. I hope you can see this option. This is a green color. So if you examine the actual class, 3 of them are versicolor and 1 is virginica. Let me now use the random forest model. You can see here the color changes for each of the 4 circles. Right now, they are being predicted as virginica. The predicted class is clearly wrong. So to summarize the discussion that we have had, in this discussion, we have seen how to build a decision tree. We have also seen how to build a random forest. We saw some of the advantages of a decision tree and also the disadvantages. We went on to build a random forest. We looked at the advantages. Let me now speak about the disadvantages of a random forest model. The first big disadvantage of a random forest model is that because we are building multiple trees, this is a time-consuming process and it is resource intensive. This algorithm is resource intensive. Thirdly, a random forest model is less interpretable as compared to a decision tree model. With this, I have come to the end of today's video. I request you to subscribe to my channel, also like and share my videos. I thank you very much for watching this video. Have a great day ahead.